You're listening to Word on the Reef, diving into marine science on the Great Barrier Reef and beyond, with Tanya Murphy and Brett Goodban. Good morning, everyone, and welcome back to Word on the Reef. I'm your host, diver and marine conservationist, Tanya Murphy. And with me, as always, is Cairns Aquarium's marine educator and fish whisperer, Brett Goodban.
Oh, good morning. We're back. How excited are we?
We are so excited to be back on air after a nearly 2-month break.
I know.
Did you do anything exciting over the last couple of months, Brett?
Well, with kids, Christmas was busy. Mm-hmm. But then being Christmas also, the aquarium's busy. So I was talking about fish most of the time.
Oh, well,
which is okay. That's cool.
Favourite thing to do. Yep. Okay, so I visited family in Western Australia and took a holiday to southern Spain and Portugal with my mum.
Yes.
But it's winter over there in the Northern Hemisphere, of course, so we didn't do any snorkelling or beaching or diving. We were just there for the art and culture. We're very sophisticated. But I got my snorkelling fix last weekend at Fitzroy Island for my partner's birthday, and oh my goodness, I love Fitzroy Island.
Yeah, Fitzroy's great.
I used to work there as a dive instructor about 10 years ago, and so I've just dived and snorkeled there so much, and it never gets old. It's still one of my favourite places on the planet. And we were snorkeling for hours every day that we were there. We saw all the turtles, eagle rays, a shovel-nosed shark, nudibranchs, crayfish, and octopus.
All the gang was there waiting for you.
Everyone was there.
Look at that. That's great.
I just did not stop clicking my camera the whole time.
Yeah.
Will I ever sort through the photos and actually get around to posting them? Unlikely, but emotionally, the memories are archived. Yep. And can I just say, I love wet season on the reef. This is an elite insider secret, which I'm spilling to all of our listeners for free. The tourists all disappear in wet season, but as long as we don't have an active cyclone, it's honestly my favourite time of year for snorkelling on the reef. Do you like wet season, Brett?
Oh, yeah, the animals are just having a big relaxing party out there, aren't they? In the wet season, they're chilling out.
Yes, and you get those... This is the only time of year where you get those glass out mornings where the water can be as flat as a mirror.
Yep.
And it honestly barely rains out at sea because there's no land mass to trigger the condensation.
That's right.
It was bucketing down in Cairns at various points on the weekend, but at Fitzroy Island we just had sunny weather and it was beautiful.
Oh, those glass out days are just magic, aren't they?
Oh, my favourite thing, get up at sunrise and swim in mirror flat ocean. Absolutely amazing. By the way, these comments are not sponsored. I'm just a big fan of Fitzroy Island, but you know, if Fitzroy Island would like to give us a free trip,
just give us a buzz.
Broadcast live from the beach, we're very open to that idea.
Oh, from the turtle hospital at Fitzroy would be good.
Yeah, that'd be amazing.
Yep.
So I'm already planning my next trip there for my birthday next month. Anyway, it's also bird and sea turtle hatching season, which is quite appropriate because it is Valentine's Day tomorrow.
Yes.
So it's a great time of year to head to somewhere like Michaelmas Cay where you can see baby birds in the nests. So adorable. And most seabirds are monogamous for life, and they're also co-parenting stars. So if there are any listeners wondering how to impress your lady tomorrow for Valentine's Day, just make sure you bring her some fishy treats to sustain her and do a bit of a dance and click your beak at her. Works every time. Yeah,
she might look at you a bit weird for a bit, but then realise that we're just weird anyway, so it's all right.
Another fun fact is penguins, the male brings the female a pebble, and if she accepts it, then they're tight for life. And so if you are at this late stage and you haven't got anything for your partner yet, and if you also don't support, you know, the commercialisation of Valentine's Day,
go and find yourself a pebble, give it a polish, fellas, right? Trust us, we know what we're doing. Hand her a pellet.
She might not really understand, but you'll have to explain about the penguins.
Well, that'd be a good discussion over a candlelit dinner, wouldn't it?
You can also donate to the Australian Marine Conservation Society on their website, and they'll send your love a virtual love pebble and the knowledge that you've done something good on Valentine's Day for the ocean. So if you love the ocean, show it some love on Valentine's Day.
Get her a bunch of pebbles.
Anyway, that's enough of us gushing about our favourite time of year on the reef. Today, we're travelling 20,000 leagues under the sea.
Oh, so excited
to uncover lost worlds.
Yep.
From rediscovered shipwrecks to uncharted underwater mountains and newly discovered deep-sea critters that have never been seen by human eyes until now.
Yep.
But first, a few marine news updates, because a lot has happened over the past 2 months while we were away. The good news to start off with, the historic United Nations High Seas Treaty officially entered into force on January 17th.
Yes.
Woo.
Big slipper hug.
Yes, after years of campaigning by conservationists, we finally have a framework to protect marine life in international waters. That's 64% of the world's oceans, previously known as the Wild West, due to them not falling under any country's jurisdiction, and there has been no regulation of what's happening out there. So the treaty lays the groundwork to protect 30% of the ocean by 2030 in marine protected areas, and that's a huge step for biodiversity. Wow. Over 140 countries have signed on, and more than 80 have ratified it into law so far. So can I hear a standing ovation from everyone out there?
Yes.
Just
big clap.
Don't crash your car, everyone that's listening.
No flipper hugs when you're driving, okay?
Anyway, how they are going to enforce that and how it will actually play out, details are still to come. We will get an expert on the show soon to break it down for us. But for today, we'll just take that win.
Absolutely.
Now, in slightly less happy news, the Marine Park Authority's latest reef health update reports sea surface temperatures offshore from Cairns, Port Douglas and Cooktown region are currently sitting about 1 degree above the long-term average.
Oh, no.
The reef regions to the north and south of us are about half a degree above average. That's still below major bleaching thresholds for now, but heat stress does build over time, and we still have over a month left of summer. So we'll keep you updated. The reef has endured 6 mass bleaching events in the past decade, including both of the last 2 years. So a third in a row would be not ideal, but fingers crossed. We'll keep our fingers, toes and flippers crossed for cooler conditions and for our global leaders to take stronger climate action so we don't have to hold our breaths like this every summer. Meanwhile, in a galaxy not too far away, a star war is unfolding.
Oh, they're back.
New outbreaks of crown-of-thorns starfish, or COTS for short, are popping up across the marine park. These coral-munching, mini-armed vacuum cleaners are being culled by dive teams as we speak. We'll have a COTS expert on the show in the coming weeks to unpack just how thorny this situation is.
Yes.
And also the wet season is doing wet season things. I just heard on the weather, on the news, that there's extreme rain warning for southeast Queensland.
Yep.
That's a long way from us. And of course, while rain is normal and welcome in wet season, we did see a record-breaking week of rainfall across the wet tropics in late January, with some days topping 200 millimetres. Heavy downpours can increase sediment runoff onto the reef, so authorities are monitoring conditions closely. So there you have it. Temperatures, thorns and torrential rain. Just another summer on the reef these days.
Yeah, it is.
But now it's time to dive into today's interview topic.
Yes.
So to set the scene, I want you all to picture this. We're aboard the CSIRO research vessel Investigator. 930 kilometres off the coast of Townsville in North Queensland and 800 kilometres east of the French South Pacific island of New Caledonia. Scientists are mapping the seafloor using sound waves, scanning an area labelled on navigational charts simply as a shipping hazard. Sounds intriguing, right? But what is it? Suddenly, the instruments light up, the sonar spikes, the scientists lean closer to the screens, and after several passes it becomes clear they've discovered a massive underwater mountain rising 3,000 metres from the seafloor, taller than Australia's highest mainland peak, Mount Kosciuszko.
Crikey.
And it's teeming with life.
Oh.
So to tell us more about this and other extraordinary discoveries in Australia's deep seas, today we're joined by CSIRO marine geophysicist, Dr. Chris Yuleridge. Good morning, Dr. Yuleridge. Welcome to Word on the Reef.
Good morning, Tanya and Brett. Thank you so much for having me on.
Good morning. Great to have you on for our first show back for this year. Let's get into it. I'm excited for this one.
Yeah, it's so great to have you on the show. Thanks for joining us. So before we dive in to find out more about this exciting underwater discovery, can you tell us a bit about yourself and how you came to be interested in marine geophysics?
Yeah, well, I currently live in Nipaluna, Hobart, on the lands of the Mulanina people, so almost as far as you can get from Cairns, but we do share a love of the ocean and the reef. So I grew up in Ku-ring-gai country in Central Coast, New South Wales, by the ocean. I spent a lot of time in the water surfing and on the beach looking at rocks. So the rock fascination started pretty early.
Yeah, everyone else is at the beach looking at the animals and you're like, wow, that's a cool rock.
Well, maybe you could collect pebbles and sell them for Valentine's Day.
Oh, yeah. I mean, my partner, she's also a geologist, and we do occasionally give each other pebbles and rocks and stuff.
That's so cool.
I mean, if you find a really cool rock and she's actually going to understand how rare and significant that rock is, I think that's great.
How romantic.
Oh, yeah. Hiking with us takes a bit of time. We're just not looking at the animals or the plants, we're just looking at the rocks. So it's a bit of a good time.
That's awesome.
But yeah, I've always had a passion for exploring and wondering what's out there. So at school, I really enjoyed physics, but I wanted it to not be theoretical. I wanted an applied way of using physics. So I thought geology would be a great way to apply that. And I found there was a field called geophysics, which just happens to be exactly right up my alley.
Amazing. So you love surfing, you love rocks, you love the ocean. It's the perfect career. Let's talk about lost worlds under the ocean. It feels like every corner of the planet has already been mapped by now. We've got Google Earth, we've got satellites, we've got drones. It feels like there's nothing mysterious left on the planet, and yet we're still discovering entire mountains underwater. Yep. Is it really true that we know more about outer space than we do about our own deep oceans?
So it's not so much space in of itself, like it is massive. It's Mars. We know more about the surface of Mars than we do about the surface of the Earth.
Wow.
So water is a very tricky thing to deal with. So light can only reach 200 metres water depth, and that's called the photic zone.
Yeah.
So below 200 metres, the water's just pitch black and dark, and sound and light can't get through it. So that's why we have a full 5-metre resolution grid of the entire surface of Mars, and makes it much trickier to map the ocean having thousands of metres of water to potentially image through. So what you do see on Google Earth, especially in deep water in the middle of the ocean, is often 500-metre resolution images from satellite altimetry data. So satellites convert non-direct measurements of the seafloor and try and convert that into some elevation. And that's full of inaccuracies. So that's why we keep finding new things. So in terms of direct measurements, only 25% of the world's oceans have been mapped by sonar. And this equates to being less than half the planet being actually mapped.
Wow. Yeah, because the majority of the planet is actually ocean. So
70%.
Yes.
Yeah, so we have a really interesting big challenge ahead of us to try and understand more with the majority of the rest of the planet.
If only the millionaires and billionaires were as interested in the ocean as they seem to be in Mars.
Yeah, maybe we want them to stay away from it, actually.
Yeah, true.
Might be a safer option.
That is a very true point. So why should we care about finding out what's at the bottom of our oceans, Dr. Yuleridge?
So we are an island nation. That's what we're all pretty proud of. We are covered by coastline, so about 60,000 kilometres of coastlines, and that includes all our islands. And we also have responsibility for a third of the Antarctic landmass as part of the Australian Antarctic Treaty. So that measurement includes part of that. And so because we have so many territories, we also get a large marine estate. So within 200 nautical miles, we have responsibility from our coastlines. So that gives us more than 13 million square kilometres of marine estate, which is twice our landmass. And so that also gives us the world's third largest marine jurisdiction behind France and the US.
That explains our national anthem, We Are Girt by Sea.
Yes, that's right.
So good.
We're extremely girt. The most girt.
We are full girt.
We are the third most girt nation on Earth.
Girt we have. All right.
And economically and for humans, there's so many reasons why we need to know more about the ocean, right?
Yeah, so the marine economy, or what we call the blue economy, is massive. So contributes to around $100 billion to the Australian economy. And a lot of this economic activity is underpinned by seafloor mapping. So things like safety navigation and identifying habitats and knowing how to zone our marine estate are really important for being able to have a healthy blue economy.
Mm-hmm. Yeah. Yeah, in order to protect our fish stocks, we need to know how many are there to begin with. And also a lot of our weather and climate is determined by the ocean and the currents and the masses that are down there, I believe. So it's got a huge impact on all of us, doesn't it?
Absolutely. Yeah, so fluid dynamics and oceanography are really complex. So things like eddies and turbulence play a really big role in how temperature and energy is spread throughout the ocean. So knowing what the topography is like will actually help our climate prediction models.
Mm-hmm. Okay.
Wow. So tell us about the voyages you've done on the CSIRO research ship, the Investigator. What is the purpose of these voyages and what sort of research is carried out on board?
Well, recently I completed my 300th day on board the Investigator.
Wow.
So
that's almost a whole year you've lived on that ship.
I have. So by the end of this year, I will have spent more than a whole calendar year on the ship,
wow.
which I'm very proud to say.
Yep.
So the Investigator, we do a whole bunch of activities. So to start with, the Investigator is part of the Marine National Facility based here in Hobart. So we're a national research infrastructure that's funded by the Australian government, and we operate it on behalf of the nation. So Marine National Facility, or M&F, that's a group under CSIRO.
Mm-hmm.
So the infrastructure, or the ship, is available for the whole Australian marine research community to use. So we have competitive applications for Australian researchers and their international collaborators to use. And we do a whole variety of science, from any geology, biology, oceanographic and atmospheric sciences. So we get a really full picture of what's happening to our oceans, and we do so many measurements. It's unreal.
Wow, you've measured everything down there. What sort of gadgets do you have on board? I'm asking this because I read about them on your website and was blown away. What sort of gadgets do you have on board the Investigator?
What cool toys do you have?
Yeah, to gather data about the ocean, because it's not just, firstly, there's the gadgets for mapping the shape of the seafloor, but you've got things for detecting marine life, things for measuring seawater chemistry, and you can even look beneath the seabed itself. It sounds almost like X-raying or ultrasounding the seafloor.
Yeah, that's actually a pretty good analogy. So, yeah, we have so many toys, and they cater for so many scientific projects and research. So we have multi-beam echo sounders for mapping, so that's the actual seafloor topography. We have a sub-bottom profiler. Now that's the sense that's able to image through the seafloor, looking at past layers through geological history. We have bioacoustic sensors, which you might like. So we ping the water column, and that can tell us the volume of animals in the water. So we can measure volumes, and even some bioacoustic specialists can identify types of animals and even some species just from the acoustic signals.
Wow. So they're like listening to the ping, and they're like, that ping sounds like...
They're listening to them having a private conversation on the shell phone. Is that what's happening?
Well, that's confidential, I think.
Yeah, okay, good answer.
Loose lips, sink ships.
That's it. We don't talk about that.
No, we just bounce really low energy sound off of animals. So what's interesting is there's particular effects where, because fishes and some animals have gas bladders, there's a difference between the water and the air. So we're actually reflecting sound off of the gas bladders, so we can get an idea of the size of the animal as well from that data too.
So cool.
It's amazing that you can do that.
Wow.
But just the idea that an expert could be listening to it going ping and be like, that sounds like a faceless cusk eel.
Yeah, or that's an eel that had way too many baked beans for dinner, so it's thrown our signal off. It's gas splattered.
Yeah, the reason I mentioned the faceless cusk eels because I saw it on your website.
That is one freaky dude.
He is a freaky dude. Anyway, sorry to interrupt.
No, that's cool. Like, there's so many deep sea abominations that we look at and pick up. It's so interesting. Yeah, so we also have a gravity meter that measures the thickness of the earth right underneath the ship, and a magnetometer, which measures the magnetic signal of the seafloor as well, so we can get a good idea of rock properties. In terms of your seawater chemistry, aspect, we have a CTD, so that's conductivity, temperature and depth. So we have a rosette, which is essentially a frame full of bottles that can go down to more than 5,000 metres water depth.
Wow.
Where we can sample the water and then take that up onto the onboard lab where we measure the water chemistry of that deep water.
That must be so exciting getting that back. You know, scientists, you're like, what are we going to find?
Oh, yeah, absolutely. And water separates into layers, so being able to measure those different layers is really cool. Yeah, we also have an aerosol lab. So we constantly feed in air through the forward mast of the ship, and that goes into a lab that measures the air chemistry as well. So we can be measuring CO2 and sulfur dioxide and be constantly measuring air quality. And part of that equipment also helps the investigator to be one of the few mobile weather stations that feed into live weather models. So you can type into weather websites or applications. If you type in VLMJ, then you'll find the investigator.
Well, I was looking on the website at the live cam that's on the investigator, so you can actually look where it is right now. And I'm watching
Tanya's actually got the mouse out and she's looking on the computer.
I'm watching the live stream, and it appears to be, well, it is in Antarctica right now. And yesterday I looked at it and there was a bunch of icebergs off the bow, but today it's in open water and it looks sunny. So that's where the investigator is right now.
Wow.
Well, I'm very happy for my colleagues that they've got calm conditions.
Yeah, the bow's barely moving, so it's not how I imagined the Southern Ocean to be. But yeah.
Tune back in on another day and
perfect storm.
Yeah, 15 metre swells and everyone's in the toilet vomiting.
So you've got ways to measure the seawater chemistry and detect marine life. Was there anything else? Any other cool gadgets?
Yeah, absolutely. We've got a bespoke deep tow camera, so we can send a camera with high-resolution video and picture in 4K. We stream in 4K in the deep sea, so down to over 3,000 metres, we can image the seafloor and take an image and footage of the creatures in their natural habitat.
Oh. You can peek into their bedroom, see what they're up to.
We need to sneak onto this ship, Tanya. I think we need to do a live radio cross from MV Explorer.
We'll put in an application for our research into marine broadcasting of radio.
Yes, please.
So let's talk about your role on the expedition, Dr. Yuleridge, mapping the seafloor. How do you do it?
Yeah, so we use multi-beam echo sounders. So we send down pings of sound. So very similar to the concept of echolocation. So sound goes from the ship down to the seafloor, bounces off the seafloor, returns to the ship, and then we can measure the shape of the seafloor from that sound.
That's pretty much how bats navigate in the dark, and also how dolphins, I think, use sound to bounce off objects.
Echolocation or something, isn't it?
Yeah, that's it.
Yeah, so it's very similar to a fish finder you can pick up off the shelf. So instead of, a fish finder has one beam going up and down, we have multiple beams, multi-beam. So we send 800 individual packets of sound into a wide swath. So it's sort of like, mapping can often look like mowing the lawn, where we're going up and down and back and making sure we're not missing any gaps. So with our swath, we achieve a width that's about 4 times the water depth. So for 100 metres of water, we've got 400 metres of across coverage. Wow. So we can get a good sense of what the seafloor looks like every time we do a line. Mm-hmm. But like, one of the incredible aspects of the investigator is that we have 3 multi-beam systems. We have a shallow, intermediate and a deep, so we can optimise the resolution and data quality for that water depth. Yep. So for example, last year when I was on the Tonga voyage, we went to the Tonga Trench, and our deepest ping was 9,888 metres. Wow. It was incredible. It took nearly a minute for the sound to come back.
Wow, that's very deep. So, so in the mapping of Australia's seafloor, you've discovered a bunch of seamounts around Australia. What exactly is a seamount?
So a seamount is a feature on the seafloor that's like somewhat skinny, that stands over 1,000 metres tall from its base. So just a mountain on the seafloor that's over 1,000 metres tall.
Wow.
In Australia, it's typically over 300 metres to classify a mountain, largely because we are a pretty flat nation, otherwise, so we wouldn't have any mountains.
Oh, on land, yeah.
Yeah, on land.
Yeah.
So these seamounts, they often form chains of volcanoes. Like, they often appear as a chain of volcanoes, and that's from a process called mantle plumes. So in geology, there's this sort of enigmatic concept of a mantle plume where lava somewhere from the mantle comes up through the crust and creates a volcano above it. And because of seafloor spreading and continental plate movement, the plates move over that mantle hotspot, or that mantle plume, which stays still. And so if you look on Google Earth, you can see that there are chains of volcanoes, like straight lines of volcanoes and seamounts. They can form in other ways, but that's the most, you'll see on maps, that's the most obvious seamounts that you can find.
That's kind of how Hawaii was formed, right? As the Earth's crust moved over this hotspot, volcanoes just kept popping up in a chain until there's a chain of islands. And some of those islands don't actually make it all the way to the surface to become islands. They just stay underwater and they become seamounts, right? But they're islands underwater in the sense of gathering points for sea life. So they're significant for sea life, aren't they?
Absolutely. Yeah, so they're often sanctuaries in the deep ocean. So seamounts are very important ecological hotspots.
So this is the part that everyone's been most intrigued to find out, Dr. Yuleridge. Let's talk about that big seamount you found in the Coral Sea. What can you tell us about it? And what was it like when you
what was that moment like? Did you go, crikey, what's that?
Well, it wasn't so much an instantaneous sort of thing that happened. It took about 4 or 5 days of dedicated surveying to get the mapping done that we did. But every time we'd get closer to this, we went in circles, and every time we got closer to the middle, we just kept being blown away. Like, surely it cannot keep looking this crazy. So there are some cliff faces that are 400 metres tall, like just straight vertical cliff faces, and there's a process called delamination where bottom currents sort of scour out the bottom of the cliff, and that destabilises the rest of the cliff, and so the rock above it just peels off, and you end up getting steepening of your seamount. You can actually see these layers in the map of these rocks just thrown about everywhere.
Didn't you describe it looking like a giant collapsing creme brulee?
I did, yeah.
So flat on the top, on the top, and then half of it's been eaten away or something.
Yeah, it does look like spoons have sort of gotten into it. But yeah, so as you said, Tanya, it's more than 3,000 metres tall from its base. It does resemble something like a circle, like a collapsed creme brulee, and it's about 30 kilometres wide. So it's quite a big feature. And we use the term discover because, like, imagine you had a blurry picture of a new species of fish. You wouldn't exactly say you discovered a new species of fish. You just sort of got, like, a blurry picture. But with this high-resolution mapping, we're able to leverage all 3 of our multi-beam echo sounders all at once. We're able to get this beautiful image.
You just deployed all your toys in one hit.
Yeah, that's right. And
so you knew something was there, but something, as in, like, you didn't have enough details until now.
I think it's probably difficult for people that haven't spent their life in the ocean like us. I mean, all we can see is just this whole new planet underwater with all these fish, and we're just dying to get in there. It's like so exciting for us. Just imagine flying in a plane on land, everyone, and then all of a sudden going, oh, look at that. There's another Mount Kosciuszko. We didn't know that was there. And species on it that hadn't been discovered and animals that we didn't think lived in that region. It's just incredible, isn't it? This is a massive find. Absolutely.
So in the chart, all we had was that there was a single data point that said 29 metres. And so the ship's captain and the bridge, they were a bit nervous going over that point because we didn't really know what was down there. But using our safe strategies of being able to survey in a way to not cause harm to the ship, we were slowly and surely able to get the full picture. And so at that peak of 29 metres deep, so it's crazy, it goes from 29 metres deep, where there's a flourishing reef, down to 3,000 metre abyss. So it's pretty incredible.
It's got all the different layers of the ecosystem.
Yeah, it's a little bit like Osprey Reef, isn't it? Where the shallowest depth at the top at high tide can be about 15, 20 metres, and then it drops off to 2,000.
Mm-hmm.
Yeah. What's interesting as well is that this reef, over time, has actually been protecting the peak of this seamount. So as sea level changes, if sea level rises slowly, then reefs generally keep up with that sea level rise, building up that reef. And when sea level drops, the reef gets exposed to the air, and then more reefs grow lower down. And so because reefs are made out of calcium carbonate, they're really hard, which makes them really resistant to erosion. So on the peak of this seamount, where this reef is, it looks really protected and looks as though the reef has been growing with sea level rise. But the problem now is that sea level rise is going a bit too quick and the ocean is a bit too acidified too quickly, so there's risks for reefs everywhere. But this was a very nice find, and there were some beautiful images they were able to take with the deep tow camera as well.
Did you get to jump in and dive on it?
Yeah, that's what I'm waiting for.
Unfortunately, we're not allowed off the ship, so we did have some marine biologists that were very eager to have a closer look at it, but...
Maybe next time.
Yeah, so charter a boat out towards New Caledonia, I suppose.
This is not safe advice to listeners. Do not undertake any...
I'm saving up money as we speak.
Okay, so Mellish Seamount, where does the name come from? Who did you name it after, or was it already named as a location on the map?
I actually don't know about the name. We just know that there was some feature there called the Mellish Seamount, and it was part of that Tasmanian seamount chain. So this is the second oldest in that chain. It's estimated to be 40 million plus years old.
Wow.
We didn't really know what the geometry of this seamount was, but we do now.
So tell us about the marine life that the biologists found on the Mellish Seamount. I just know we're going to run out of time, by the way, because we've only got 15 minutes left and I've still got so many things I want to know.
5 pages of questions.
Tell us everything. But anyway, let's talk about the marine life.
Yeah, so there's heaps of abundant corals. I'm a rock nerd, so I don't know a lot about fishes and species, but just know there's a lot of them. There's some sharks, and some invertebrates. I know that word.
Like
so
rocks.
In the footage... So in the footage, there was plenty of life to be seen, and it was really spectacular to be seeing it in real time.
I want to advise everyone to go to the website and look up the Investigator expedition to the Coral Sea, and honestly, some of those creatures in the pictures look like aliens. And as I mentioned earlier, I have a personal favourite in the faceless cusk eel.
Yes, he has a face for radio, that thing.
I won't ask you about it though, since, as you mentioned, you're more of a rock person. Is there anything else you want to say about the Mellish Seamount before we talk about some of the other things you've discovered in other parts of the sea?
I'd like to say that the science participants did a really interesting work and great work on sampling the seamount. So we sampled all over this mount for new marine species, and I'm sure there's more discoveries and papers to be coming out about this in the future.
Yes, we'll keep our eye on it. Yep. Make sure you let us know if any more interesting discoveries come out of it, and we'll get you back on the show down the track after a few more expeditions. But so beyond the Mellish Seamount, what are some of the other remarkable discoveries from your time on the Investigator? We'll have to whip through them in the next 13 minutes.
Well, I'm not going to take all the credit. It's a big team, big community effort to get any of this information. But from what I've seen, we have uncovered new shipwrecks, including the Blythe Star down here in Tasmania. So it was a really fantastic find.
When did that sink and go missing?
I can't remember off the top of my head, but it was several decades ago, and that wreck and that sinking led to a lot of the maritime safety laws that we enjoy today.
And I know that the Investigator, whether or not you were aboard, I know the scientists of the Investigator have found, I feel like it's more than a dozen shipwrecks which were lost for a long time, including World War II shipwrecks, which were, so you're solving countless mysteries that have existed for a long time. It's really exciting.
Yeah, absolutely. I think as well what's cool is that we're also helping to uncover Aboriginal cultural heritage as well. So with the last glacial maximum 20,000 years ago, sea levels were about 150 metres lower. So that means a lot of the continental shelf was exposed to air, and there would have been people living on there for thousands of years. So it's been fantastic having Indigenous peoples on board and becoming really excited about shelf features that we see in our multi-beam systems.
What sort of things are you talking about? Like evidence of encampments, fishing, what sort of things can you see? Or is it more just pinpointing the location where they used to live? Or
Yeah, so topographic highs and rock features and caves that stand out above the plains. Mm-hmm. So we can also see as well in the sub-bottom profiler paleo channels, so river channels that used to exist in the past. So they would have been transport pathways as well.
That's so cool.
So
that's amazing.
Yeah.
I mean, having Indigenous knowledge holders on board, I kind of imagine how emotional that would be because they know it all from their oral history. So it'd be their first time seeing it.
To physically see it, that'd be pretty special for them, wouldn't it?
Yeah.
Wow.
It's incredibly special.
Yeah.
And they'd be like, well, the stories were right. We were told that there was this river here. We've known in our oral history that we lived on this ridge or cave, and then they get to see it. And
what a privilege that is for the investigator and your team to be able to provide that to them too.
Absolutely.
Wow.
What else have you been discovering down there?
So, mid-ocean ridges, canyons. Last year we surveyed the Hunga Tonga volcano out in Tonga. So we were assessing impacts to the local area, such as submarine cables being cut off. So essentially Tonga having no comms for a few weeks.
So if anyone forgot, because I kind of did forget, so I had to look this up again. This is the volcano that erupted spectacularly in 2022. It blasted ash 58 kilometres into the atmosphere, killing at least 5 people and severing undersea telecommunication cables, cutting Tonga off from the rest of the world for a week. I remember it now. I think we had...
Yeah, it was a big one.
The sky changed colour, even here in Queensland, and we had pumice. I'm pretty sure that's when we had pumice washing up.
That's right.
Which is, for anyone that doesn't know, pumice is a floating rock formed by volcanic foam. Floating rocks. We had them floating up onto our islands and things. So that was the Tonga volcanic eruption 2022, and so that's pretty brave, just going right over the top of this giant volcano.
Well, now's the best time. It's got no magma in it, so
it's unloaded.
It's had its big cough. That's it now.
Yeah.
Yeah, okay.
That's right. And other things as well, like we have done some surveying on the Great Barrier Reef before. You might have heard of Halimeda bioherds, which are really important ecosystems and species for reef health, so they're just off the reef a bit lower.
I actually haven't heard of them. So off the edge of the drop-off, are they?
Yeah, so just to the east of the Great Barrier Reef, there's flatter sandy plains, and there's these circular communities of microorganisms that form bioherms. They're called Halimeda.
Bioherm. Okay.
Yeah.
We're Googling this.
They form these really interesting circle patterns, and so they control some of the nutrients that go on and off the Great Barrier Reef, which are really important.
Just imagine all of these almost unheard of things that are just going on down there, which control hugely important parts of the ocean. Yeah. And it's the first time I'm hearing about it because all we get to look at when we go diving is down to 30 metres. So amazing. Yeah, the ocean's a big interconnected system where things from far away can really impact things that are local to you.
Did you say they were bioherms?
Yes.
Okay.
Everyone at home's Googling them.
I can hear the tapping of keyboards. He said what? Okay, that's cool. Is there something that stands out for you being the rock king that got you really excited in your adventure?
Rock king's pretty generous.
Rock god?
Rock god, there you go.
Rock star.
Oh, that's even more.
Stonefish?
I'll say enthusiast, but... yeah, just being able to see features that nobody else has seen before.
Yeah.
Like, whether they're on the seafloor. Like, to me, the seafloor is the surface.
Yep.
Like, to a lot of people, probably the water surface is the surface, but to me, the seafloor is the surface.
You see everything upside down.
Yeah.
There you go.
Our elevation is opposite, so down is positive. And being able to see structures beneath the ground too. Like, my PhD is in acoustics, so subsurface acoustics. So just love being able to see features that no one else would know about otherwise.
Yep.
You can have a perfectly flat surface, but there's some amazing geometry and features They're really steep and doing some really interesting things underground, and we can see hundreds of millions of years into the past.
That's a storybook, isn't it, at the bottom of the ocean, where it all started.
It's so amazing. We don't have much time left, so I've got a couple of really important questions that we'll try to do rapid fire and concise. With methods of ocean surveying, I'm a little bit concerned to hear about seismic methods. I have concerns about impacts on marine life. Are there risks associated with these techniques, and how do you minimise harm?
Yeah, that is a common concern. So we generally separate seismic systems from acoustic mapping systems, because acoustic mapping systems are generally lower energy, higher frequency. But you can rest assured that our sounders cause little to no harm to marine biota. There's pretty much no tangible evidence that our sounders have negative impacts on biota.
Excuse my ignorance, but is the sonar, I mean, all boats have that, so that must be quite common. But when I've heard about seismic blasting, that's the really loud underwater pressure cannons. Do you use that?
Yeah, so on the ship we do have a seismic system. We say seismic surveying because we're not just blasting the water for the fun of it. We're trying to understand more about the subsurface and be able to understand more about the Earth and our planet. And generally, the impacts of seismic are broadly exaggerated. So a Geoscience Australia study commissioned by a Green senator determines that without more information, generalisations about impacts among taxa by air guns, that we call them, are not scientifically valid. So it's really hard to actually measure. So a lot of the measurements are done in labs, not necessarily out in marine environments. But taking these seismic surveys is really important to understanding our past climate. Yeah. So, for example, with this data, we've been able to identify the greatest mass extinction event, the Permian, 250 million years ago, wiped out 9% of all life on the planet. So we can look at that through the fossil record. And so it might be a similar story where lava had come up through a petroleum basin in Siberia, burnt off all the hydrocarbons, CO2 went into the atmosphere, caused global warming, and then mass extinction. So it's a pretty familiar story.
Yeah, it is.
The only problem is this time it's not caused by lava, it's caused by us.
Yes.
So the good news is there's something we can do about it this time. We've only got a couple of minutes left, and I really want to get this one in, but it'll have to be concise. There's a growing interest globally in deep sea mining and mining the seabed for resources, which has conservationists concerned. Do you think the information you're gathering could ever be used or potentially used by industries looking to exploit the ocean floor?
That is an interesting topic. I can't exactly say how deep sea mining is going to operate, but pretty much any activity on the seafloor is underpinned by seafloor mapping data. So like with any tool, it can be used for different things, like how on land we use satellite data for terrestrial mining. So it depends on what the uses are. Really.
There's obviously a lot we can use this information for protecting what's down there, but in the wrong hands it could be used to do non-animal friendly activities as well.
There's always that's the age-old question, isn't it?
We don't want Dr. Evil getting hold of it.
But of course, your job is to find the data and not to determine how other people use it, I suppose.
Yeah,
that's right.
Yeah, well, I could talk about this for much, much longer, and I'm sure you could too. We'll have to get back on the show at another stage and just keep us updated in any new mountains that you discover down there. Yeah. But yes, sadly, that's all we have time for today. So Dr. Chris Yuleridge, marine geophysicist, mapping Australia's seafloor with CSIRO. Thanks for all your amazing work, and thanks so much for joining us on Word on the Reef today.
Thank you so much for having me. Check out ozseabed.com to check out all of our marine bathymetry data, all our mapping data.
I'll be doing that this afternoon.
Thanks to you, all our listeners, for joining us on Word on the Reef. With me, Tanya Murphy, and co-host Brett Goodban. This show is broadcast live from the Cairns FM studio, which is on the land of the Yidinji people. We'd like to extend our respect to elders past and present. We'll be back next week with more marine science adventures, 10 a.m. every Friday on Cairns FM 89.1. That's all for this week. Best fishes, and see you next time.
Safe diving. Bye.